Okay, so consider a circle. I'm gonna release a circular wavefront from the bottom of this circle. Okay, I'm gonna watch what it does as it progresses along. So let's go ahead and release that. How do I do this? I just hit go. So you see here there's a circular wavefront. Let's zoom in on that. There's a circular wavefront that I'm releasing. Let's do it again. From the bottom of the circle, okay? And this wavefront is just gonna progress up. And we're gonna watch what it does as it progresses up. Okay? Let it. The first phenomenon one observes, okay? I'm gonna point you guys to this area where there has been a split, and you get into this side fractal of sorts, right? So you have the original arc of the circle of the wavefront. This is a perfect circular arc centered on this point. Now the circular arc has been disrupted to form a sequence, an infinite sequence, a fractal-like infinite sequence of curves. And each one of these curves is not a circle, it's something else. And you get this sequence of inverted curves here. So let's watch this process again. Let's go back to the bottom. I'm going to reset and say go. Now this fractal is present from the very first moment, but it's pretty small, so we can't see it here. We can't numerically see it. It's only going to become more macroscopic as this wave progresses. So now you get the second phenomenon where this intact part of the original wavefront, okay, is going to shrink to a point. So it shrunk to a point there. When it shrunk to a point, let's go back in time so we can watch that. Okay, so it shrinks to a point right here. When it shrinks to a point, the secondary arches take over and you get this new regular central arch. Okay, so let's keep going with that. You can see here that now the entire shape has morphed to a sequence of the sort of inverted infinite sequence of inverted arches. The central arch is no longer a circle because it was formed by the union of those two secondary arches, and we're going to start getting a pretty interesting sequence of phenomena. This particular moment here is very interesting because you get this sort of ghostly like shape. Let's go back in time. So here we are. So we get this kind of a ghost profile. But we can keep going, right? So we can keep going, we can keep observing, keep seeing this whole thing evolve. And it's just going to go on forever, and it's going to be adding more and more complexity back and forth. So this is the wavefront of this is the evolution of a circular wavefront starting from the bottom of a circle. You get these side fractals. It keeps going, it regularizes itself. Then you get into this moment here where things invert a second time. And then you get the octopus, or the little ghost. There you go. I like to call this the octopus. Okay? And then it keeps going, and it morphs, and it changes, and it does a bunch of nice things. Okay, now let's do the same thing for an ellipse. Let's pick, so I'm going to reset this. I'm going to pick an A over B, say what we have here. Let's go for an A over B equals 1.5. My favorite is 1.5. So now I have an ellipse. Okay, now I can repeat the experiment. I'm going to launch from the bottom, launching the circular wavefront. You start getting these side fractals. They're not exactly the same as the circular ones, but they are related. You get similar phenomena. And then you just get beautiful stuff going on here. It gets pretty complicated. And so forth and so on. Okay, now let's do another experiment. Instead of launching it from a bottom vertex, let's launch it from the left vertex. Okay, let's do that. Let's see what happens. So you're getting those fractals again. They seem to be dying off more quickly. Now, did you see that first phenomenon? Let's go back here. See if I can go back in time. Definitely can. You get this nice annihilation phenomenon as I'm going back in time. You see, I got an annihilation phenomenon right here near the focus. Okay, now let's keep going. Let's keep going forward. So I'm going to get things that look similar to the circle, but they're not exactly the same. I'm getting this huge wake of fractalic tails, right, that is just increasing and just keeps going on and on and on. So there's a lot of analysis that can be done here. I'm starting to polygonize my thing because I don't have enough sampling, but that's fine. Okay, now let's do another experiment. Let's launch from a focus. So I'm on a focus here. I'm going to launch a circular wavefront from this focus. Let's look at the beautiful thing that happens here. I start with a circle. Now at some point, this side of the circle is going to interact with this side of the ellipse. When it interacts, you get this beautiful phenomenon. This automatically becomes, by virtue of the geometry of the ellipse, this automatically becomes a circular arc, not centered on this one, as is this one, but centered on the other focus. So let's go back. You start with a focus. As soon as you get that bounce, whatever goes after the bounce is already part of an arc centered on this focus. At the center position, the two sides of this lens are identical. You have this side of the lens centered on the red dot and this side of the lens centered on the white dot. And of course this thing is going to annihilate on the other focus. And you get the standing wave. You're going to keep doing the same thing back and forth. Ignore the numerical noise there. And then you're going to annihilate here, and you're going to stay in this standing wave, right? The same kind of standing wave happens if you launch from the center of a circle. You start in the center of the circle, and you just bounce back. A circle can be seen as an ellipse with two foci coinciding, so this phenomenon is not different from the one we just saw. Okay, all right, another experiment. Let's go to the ellipse. And what we're going to do is we're going to put a point in the mid-major. So I'm going to just start my circular waveform from midpoint on this left side of my major axis. So let's do it. So you get a slightly symmetric thing, which has nonetheless beautiful geometry. You're welcome to try to analyze this. There's a lot of richness here. It goes through topological changes, etc., etc. Okay, now let's do a final experiment. I'm going to launch from the center of the ellipse. So now I'm in the center of the ellipse, and I can launch. Now this one has several beautiful faces. We're going to go over it a couple of times. Now I'm going to stop here because this is the most mesmerizing part of the sort of early evolution. I don't know if you noticed, we start with a regular curve, a circle, right? As soon as it bounces against the wall, you start forming these tips here. Okay, I don't know if they're properly called cusps, but you can see that it's non-differentiable. As this thing advances, you go back to what looks like a regular curve. Okay, then it crosses over, and now you have these four cusps. It knocks against the wall. Now you're getting 4 tips against the boundary, and you have these internal cusps here, so 4 and 4, there's 8. But look at what's going to happen now. The middle cusps have annihilated themselves, and this part is regular. However, we still have these 4 tips here, okay, these 4 corners. But somehow, the whole curve now has become regular again. So I'm mesmerized and fascinated by how these wavefronts can go from regular to cusped, back to regular, and so forth and so on. And here you're going to get a very interesting phenomenon. These 2 loops are going to annihilate themselves at the foci. You see, they're getting squeezed, and now they've just annihilated themselves exactly on the focus, or on the foci. Even though we did not start, this original evolution here, simulation from the foci, somehow this information is there, and the wavefront knows that. It knows that this ellipse has these foci. How can it know that? Well, after it's interacted with the boundary several times, it's going to somehow compute where the foci are. Okay, and this is another fascinating phenomenon. So let's continue. And you get more complicated, non-regular shapes. Did you see what we went through? Let's go back to that Star of David. So we got this other phenomenon. There you go. This is remarkable, right? How can the symmetry be present here after so many bounces? So let's keep going. Here's another remarkable coincidence. Right here, everything is going through the center. I'm losing a little bit, polygonalizing a little bit, because I'm sort of so far away from the initial conditions that I'm starting to lose precision, but let's keep going. And this thing is just going to keep going on and on and on, and I think I'm too far away now. I'm completely polygonized. Okay guys, so I just wanted to show you a few of these experiments. I'm going to make a second video with more information soon. Thank you very much.